chemists in the way I trust those of surgeons, plumbers, and other possessors of arcane and privileged information. But I couldn't, for the life of me, conceive how any human mind could work out what spaces thousands of miles below us that no eye had ever seen and no X-ray could penetrate could look like and be made of. To me, that was just a miracle. That has been my position with science ever since. Excited, I took the book home that night and opened it before dinner, an action that I expect prompted my mother to feel my forehead and ask if I was all right. And starting with the first page, I read. And here's the thing. It wasn't exciting at all. It wasn't actually altogether comprehensible. Above all, it didn't answer any of the questions that the illustration stirred up in a normal, inquiring mind. How did we end up with a sun in the middle of our planet? And how do they know how hot it is? And if it is burning away down there, why isn't the ground under our feet hot to the touch? And why isn't the rest of the interior melting? Or is it? And when the core at last burns itself out, will some of the Earth slump into the void, leaving a giant sinkhole on the...
Police reported ahead.
Giant sinkhole on the surface? And how do you know this? How did you figure it out? But the author was strangely silent on such details. Indeed, silent on everything but anticlines, synclines, axial faults, and the like. It was as if he wanted to keep the good stuff secret by making all of it soberly unfathomable. As the years passed, I began to suspect that this was not altogether a private impulse. There seemed to be a mystifying universal conspiracy among textbook authors to make certain the material they dealt with never strayed too near the realm of the mildly interesting, and was always at least a long-distance phone call from the frankly interesting. I now know that there is a happy abundance of science writers who pen the most lucid and thrilling prose. Timothy Ferris, Richard Fortey, and Tim Flannery are three that jump out from a single station of the alphabet. And that's not even to mention the late but godlike Richard Feynman. But sadly, none of them wrote any textbook I ever used. All mine were written by men, it was always men, who held the interesting notion that everything became clear when expressed as a formula, and the amusingly deluded belief that the children of America would appreciate having chapters end with a section of questions they could mull over in their own time. So I grew up convinced that science was supremely dull, but suspecting that it needn't be, and not really thinking about it at all if I could help it. This, too, became my position for a long time. Then, much later, about 4 or 5 years ago, I suppose, I was on a long flight across the Pacific, staring idly out the window at moonlit ocean, when it occurred to me with a certain uncomfortable forcefulness that I didn't know the first thing about the only planet I was ever going to live on. I had no idea, for example, why the oceans were salty, but the Great Lakes weren't. Didn't have the faintest idea. I didn't know if the oceans were growing more salty with time or less, and whether ocean salinity levels was something I should be concerned about or not. I am very pleased to tell you that until the late 1970s, scientists didn't know the answer to these questions either. They just didn't talk about it very audibly. And ocean salinity, of course, represented only the merest sliver of my ignorance. I didn't know what a proton was, or a protein. Didn't know a quark from a quasar. Didn't understand how geologists could look at a layer of rock on a canyon wall and tell you how old it was. Didn't know anything, really. I became gripped by a quiet, unwanted, but insistent urge to know a little about these matters, and to understand above all how people figure them out. That, to me, remained the greatest of all amazements, how scientists work things out. How does anybody know how much the Earth weighs, or how old its rocks are, or what really is way down there in the center? How can they know how and when the universe started, and what it was like when it did? How do they know what goes on inside an atom? And how, come to that, or perhaps above all on reflection, Can scientists so often seem to know nearly everything, but then still not be able to predict an earthquake, or even tell us whether we should take an umbrella with us to the races next Wednesday? So I decided that I would devote a portion of my life, 3 years as it now turns out, to reading books and journals and finding saintly, patient experts prepared to answer a lot of outstandingly dumb questions. The idea was to see if it isn't possible to understand and appreciate, marvel at, enjoy even, the wonder and accomplishments of science at a level that isn't too technical or demanding, but isn't entirely superficial either. That was my idea and my hope, and that is what the book that follows is intended to do. Anyway, we have a great deal of ground to cover, and much less than 650,000 hours in which to do it, so let's begin. Part 1, Lost in the Cosmos. They're all in the same plane. They're all going around in the same direction. It's perfect, you know. It's gorgeous. It's almost uncanny. Astronomer Geoffrey Marcy, describing the solar system. Chapter 1, How to Build a Universe. No matter how hard you try, you will never be able to grasp just how tiny, how spatially unassuming is a proton. It is just way too small. A proton is an infinitesimal part of an atom, which is itself, of course, an insubstantial thing. Protons are so small that a little dib of ink like the dot on an I can hold something in the region of 500 billion of them, or rather more than the number of seconds it takes to make 500,000 years. So protons are exceedingly microscopic, to say the very least. Now imagine, if you can, and of course you can't, shrinking one of those protons down to a billionth of its normal size into a space so small that it would make a proton look enormous. Now pack into that tiny, tiny space about an ounce of matter. Excellent. You are ready to start a universe. I'm assuming, of course, that you wish to build an inflationary universe. If you'd prefer instead to build a more old-fashioned, standard Big Bang universe, you'll need additional materials. In fact, you will need to gather up everything there is, every last mote and particle of matter between here and the edge of creation, and squeeze it into a spot so infinitesimally compact that it has no dimensions at all. It is known as a singularity. In either case, get ready for a really big bang. Naturally, you will wish to retire to a safe place to observe the spectacle. Unfortunately, there is nowhere to retire to, because outside the singularity, there is no where. When the universe begins to expand, it won't be spreading out to fill a larger emptiness. The only space that exists is the space it creates as it goes. It is natural, but wrong, to visualize the singularity as a kind of pregnant dot hanging in a dark, boundless void. But there is no space, no darkness. The singularity has no around it. There is no space for it to occupy, no place for it to be. We can't even ask how long it has been there, whether it has just lately popped into being like a good idea, or whether it has been there forever, quietly awaiting the right moment. Time doesn't exist. There is no past for it to emerge from. And so, from nothing, our universe begins. In a single blinding pulse, a moment of glory much too swift and expansive for any form of words, the singularity assumes heavenly dimensions, space beyond conception. The first lively second, a second that many cosmologists will devote careers to shaving into ever finer wafers, produces gravity and the other forces that govern physics. In less than a minute, the universe is 1,000,000 billion miles across, and growing fast. There is a lot of heat now, 10 billion degrees of it, enough to begin the nuclear reactions that create the lighter elements, principally hydrogen and helium, with a dash about 1 atom in 100 million, of lithium. In 3 minutes, 98% of all the matter there is, or ever will be, has been produced. We have a universe. It is a place of the most wondrous and gratifying possibility, and beautiful too. And it was all done in about the time it takes to make a sandwich. When this moment happened is a matter of some debate. Cosmologists had long argued over whether the moment of creation was 10 billion years ago, or twice that, or something in between. The consensus seems to be heading for a figure of about 13.7 billion years. But these things are notoriously difficult to measure, as we shall see further on. All that can really be said is that at some indeterminate point in the very distant past, for reasons unknown, there came the moment known to science as T equals 0. We were on our way. There is, of course, a great deal we don't know, and much of what we think we know, we haven't known or thought we've known for long. Even the notion of the Big Bang is quite a recent one. The idea had been kicking around since the 1920s, when Georges Lemaitre, a Belgian priest scholar, first tentatively proposed it. But it didn't really become an active notion in cosmology until the mid-1960s, when 2 young radio astronomers made an extraordinary and inadvertent discovery. Their names were Arno Penzias and Robert Wilson. In 1965, they were trying to make use of a large communications antenna owned by Bell Laboratories in Holmdel, New Jersey. But they were troubled by a persistent background noise, a steady, steamy hiss that made any experimental work impossible. The noise was unrelenting and unfocused. It came from every point in the sky, day and night, through every season. For a year, the young astronomers did everything they could think of to track down and eliminate the noise. They tested every electrical system. They rebuilt instruments, checked circuits, wiggled wires, dusted plugs. They climbed into the dish and placed duct tape over every seam and rivet. They climbed back into the dish with brooms and scrubbing brushes and carefully swept it clean of what they referred to in a later paper as white dielectric material, or what is known more commonly as bird shit. Nothing they tried worked. Unknown to them, just 50 kilometers away at Princeton University, a team of scientists led by Robert Dickey was working on how to find the very thing they were trying so diligently to get rid of. The Princeton researchers were pursuing an idea that had been suggested in the 1940s by the Russian-born astrophysicist George Gamow, that if you look deep enough into space, you should find some cosmic background radiation.